Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad Zaidi bin Khairul Zaman. I'm a student University Kuala Lumpur, Malaysian Institute of Aviation Technology. Today, I would like to teach you about light and sound. Before we go to the further, I would like to introduce you about the wave. Okay, what's meant by wave? Wave is an oscillation accompanied by a transfer of energy that travels through the space or mass. Frequency refers to the addition of time. There is a two wave. Firstly, a transverse wave. Transverse wave is a particle of medium are displaced in the direction perpendicular to the direction of energy transport. The particle do not move along with the wave, they simply oscillate up and down about their individual equilibrium position as they are passes. Longitudinal wave. In the longitudinal wave, particles of the medium are displaced in the direction parallel to the energy transport. The particle do not move down the tube with the wave, they simply oscillate back and forth about their individual equilibrium position. The wave is seen as the motion of the compressed region is a pressure wave which move from left to the right. Okay, to make it understanding, we can use the spring to identify the transverse and the longitudinal wave. Okay, uh, as we can see that transverse wave are produced up and down movement, while the longitudinal wave produce parallel movement, which is left to the right or right to the left. Okay, longitudinal wave can have a produce two situation, which is compression and reflection. As we can see that compression is the spring are close together, while the reflection is far apart. Okay, there's a few example of wave. The firstly is the water wave. Water wave is produce both of the wave, which is transverse and longitudinal wave. Why I say like that, because wave produce a position circulation position, which wave consist of all motion which up and down, left and right. So, secondly is electromagnetic wave. Electromagnetic wave which can travel through the vacuum of outer space. Mechanical wave, unlike electromagnetic wave, require the presence of material medium in order to transport the energy from one location to another location. So, as we can see that these are few example of electromagnetic wave. One of them is a light. Okay, light. Light is part of our lesson. So you can see that light is part of the electromagnetic wave with is transverse wave with have 400 to 700 wavelength meters. Okay, we move to the properties of the wave. We can to read in the graph. So they have amplitude, wavelength, crest, top. Okay, wavelength is the distance between the crest, as we can see, and the amplitude is the highest position of the highest position in the crest. So these are velocity and frequency. So interference. Okay, interference or superposition occur at point where two or more wave meets. There are two common interference: constructive and destructive. Constructive is two or more equal frequency of phase resulting in their mutual reinforcement, producing a single amplitude equal to the sum of the amplitude of the individual wave. While the destructive is two wave or equal frequency of opposite phase resulting in their cancellation, where the negative displacement of one always coincides with the positive displacement of the others. As we can see that destructive and constructive, with the dot is the destructive, while the constructive is the smooth line. Standing wave, also known as a stationary wave, is a wave in a medium which each point on the axis of the wave has an associated constant amplitude. The location at which the amplitude is minimum are called knots, and the location where the amplitude is maximum are called anti-knots. Okay, we done with the wave. Let's move to the light or optics. Okay, light enables us to see object. Light travels in a straight line. Light have moved in the high speed with 186 miles 186,000 miles per second, and the direction of light can be changed by the reflection, absorption. Light also part of electromagnetic wave. Okay, light dispersion through the glass prism. Sir Isaac Newton was the first person discover the band of color known as spectrum using glass prism. As we can see that the light is refract to the glass prism and disperse the six color: red, orange, yellow, green, blue, violet with indigo being difficult to distinguish. Light pass the glass prism by diffraction. This is called dispersion of the light. Okay, we move to the reflection, law of reflection and reflection. Okay, reflection is the change in the direction of light wave when it bounces off the boundary. There are two laws of reflection. The angle incidence is equal to the angle reflection. The reflect rays lies in the same planes as the incidence ray and the normal at the point of the incidence. This law applies equally to the curve and a flat surface. This as you can see, that's the the example of the law of reflection. As we can see that angle incidence is equal to the angle reflection. This mirror reflection, specular reflection, diffuse reflection. Specular reflection is many angle of light in the smooth flat and the smooth surface, while the diffuse reflection is a gradual surface. Total internal reflection. Total internal reflection occurs when the angle of incidence in the denser medium must be greater than the critical angle. They move from the denser to less than. Okay, total reflection. This is an example of total internal reflection. This is also the example of total internal reflection. As you can see, the optic lights occur the total internal reflection in their tube. Is used widely in the aircraft telecommunication. Okay, refraction. What's meant by reflection? Reflection is move from the difference medium, which either less than to the denser or less than or denser to the less than. Okay, angle of denser medium bends toward the normal lines, while the angle of less than bends away from the normal lines. As you can see that. Refractive index. Refractive index depends on the wavelength of the light. In the vacuum, light wave travel 3000 km per second, whereas in the glass, velocity falls to the 2000 km per second. This is Snell's law, as you can see. This few example of Snell's law. You can see that solving problem. Real depth, apparent depth is occur in the water. The position of the eye, a position of object, not in the position what we see in from the space. This caused by the reflection. Okay, there is a difference between the reflection and refraction. Reflection has the same size with the object but change in the position, while reflection travel from a different medium, velocity different, direction change. This is a mirror. They have a convex, concave mirror, as you can see. These are few properties of concave and convex mirror. You can see that their properties. Lens, convex lens, concave lens, converging, diverging. You can see. Calculation of power met. Power 1 over frequency, 1 over f. These other properties, other calculation. You can see. U, distance of object from the lens. V, distance of object from the lens. F, focal length of the image. Focal length of the lens. Okay, there's properties that you can see. There's the diffraction, interference, you can see. Okay, sound wave. Sound is a vibration that propagates as the typical audible mechanical wave of pressure displacement through a medium such as air or water. In physiology or psychology, sound is the reception of such wave and their perception by the brain. Sound can propagate through compressible media such as air, water, and solids are longitudinal wave, and also as a transverse wave in the solid. So the sound source creates vibration in the surrounding medium. As the source continues to vibrate the medium, the vibration propagates away from the source at the speed of the sound, thus performing the sound wave. At a fixed distance from the source, the pressure, velocity, and displacement of the medium vary in the time. At the instant in the time, the pressure, velocity, and displacement vary in the space. Note that the particle of the medium do not travel with the sound wave. Okay, as we can see, there is a few example. Doppler effect. Okay, Doppler effect is the change of frequency of length for the observer moving relative to its source. As you can see, there's a difference between the shorter wavelength and longer wavelength, higher frequency, lower frequency. As you can see, shorter wavelength have a higher frequency, longer wavelength have a lower frequency. Okay, sound intensity, you can see determined by amplitude of a sound wave. Higher amplitude, higher the sound. Smaller change in sound intensity to humor can be detected, measured by the decibel. Okay, this is a few can see the properties of the sound intensity. Frequency. Frequency is number of vibration complete per second. Higher the sound, higher the pitch. As you can see, sound propagation have a three common factor. Source, medium, detector. Range of human can be here to the 20 to the 20,000 hertz. Doppler effect. Okay, as you can see, Doppler effect. Summation. Shock wave. Okay, what I mean by shock wave? Okay, shock wave is the example of application is in the aircraft. As we can see that in the aircraft, shock wave occur when the speed of aircraft equal to the speed of sound. Is called a supersonic speed. Speed of sound is the speed of which the mechanical vibration of sound travel in the elastic medium, varies with temperature and altitude. Mach number. Mach number is using used as identification to identify the ratio of the speed airplane to the speed of sound in the same atmospheric condition. Mach number is calculated by the speed of sound divided by the speed of the sound. No. Mach number is calculated by speed of aircraft divided by speed of sound. Resonance. The natural frequency of given object vibrates naturally or without the external force. Two objects have a similar frequency. If one vibrates, the other can be moved to. Destructive force. Wave properties. You can see frequency, Doppler effect. In the case sound wave, the frequency is given by the rest, sound velocity of the listener, sound velocity of the source. Okay, we done until here. So thank you for watching my videos, and I hope you enjoyed it. Thank you.